Well, hey everybody, hope you're doing well. I think we've sorted out our audio problems that we had yesterday. I don't know if our volume levels were a little bit low on the microphone, but if you notice problems like that during the webcast, jump in with all caps and let me know. There you can see Venus. I got a quick shot of that this evening about 20 minutes ago, off on the southern horizon, and you should be able to see that also. Kind of a neat sight out there, and I will try to get that telescope out there sometime in the next week or two before it gets really cold. The weather picture for Texas. My volume levels are probably looking a little bit hot, maybe a little high, so I'm going to bring it down a notch. Let me know if there's any problems there, okay? Okay, so there we go. Texas once again under southeasterly flow. And I've added streamlines using digital atmosphere here. And you can see the flow off the Gulf into Texas. And it's still remaining kind of dry. So we know we have some downward motion along with this southerly flow. And you can also see a little bit further up to the north, there's a bit of a convergence line right here, and even a little bit of convergence, point convergence right here. So we have a bit of cyclogenesis on the lee side of the Rockies, and possibly the tail end of a cold front coming in from Minnesota, kind of like that. So that'll be something to watch as we go through the charts here. Further up north, you can see that we have, let me move the map so you can check that out. Pacific air, very strong downslope flow in the Dakotas. So even though we have frontal passage with a cool front out to the east, we're still looking at very warm weather back behind the front. And that's due to that adiabatic subsidence behind the front as air moves from 7,000 to 8,000 foot elevations down to 4,000 to 3,000 foot elevations. Out in the Pacific Northwest, still looking kind of unsettled. You can see that we've still got that southerly flow there in Oregon and Washington, and overcast skies there, so that's indicative of maybe a front to the south or the southeast. And the rest of the southeast is under, or southwest, sorry about my voice, is under westerly flow. So here's something new, so we're not looking at the same old charts every day. I guess a lot of you are out handing out trick-or-treats, Halloween candy, but for those of you who have stuck it out, I've got some AWIPS maps for this evening. And this is the system that the National Weather Service uses to plot their weather maps in station. So we're looking at this high cloud, cirrus and cirrostratus, from Arizona to Kansas. And as you look northward, you can see very more strongly developed mid and low cloud layers. So we can tie that a little bit into the upper flow using the 250 millibar analysis. And this is showing, usually when we see this kind of pattern, we're probably looking at a subtropical jet coming up from the Pacific, kind of like that. And we tend to get clouds on the positive inside, which means equatorward, and a lack of clouds on the other side. So here we have subsidence. So this is a subtropical jet, and this is going to be centered up at about 30 to 40,000 feet, possibly even higher. And we've probably got a polar front jet running something like that. So that's going to be something to look at. And you probably know from watching these weathercasts that we've probably got a bit of a shortwave right here in Nevada, and possibly another one in Montana. So we can add on vorticity. Vorticity is a very good way for finding upper level lift. Well, our chart is kind of messy, so I can't really pick that out too well, but I'm going to show you one center right here. This is a cyclonic vorticity center, and I'm outlining that very quickly. And when we have that, we expect to see a vorticity lobe across the flow, and we would have upward motion ahead of that and downward motion behind it. So why is the cloud here kind of out of phase? You can see it's dragging a little bit. Well, one answer is going to be the product time, and that's something you have to kind of stay aware of. You can see that the satellite imagery is for 2315, and the upper level data is for 0Z. So that's a 45-minute difference, which means if the upper level flow is 80 knots, that's going to move 60 miles between this product and that product. So things are going to be a little bit off here. So if we take that into account, yeah, the high cloud should be a little bit further downstream. And that syncs up very well with the short waves as indicated by this NAM model. So you can kind of use this to kind of verify your model and see how it's doing. So that's something that you'll do from time to time and make sure everything is on track. Here's another example. See this Bear Clinic system right here over northern Nevada. So we're going to expect to find possibly a shortwave in this area right here. Something like that. So do we find that with these red contours? Well, we don't really find so much a lobe as an area of decreasing vorticity out in this area. So that kind of corresponds pretty well. The clouds have probably shifted here also, but the model pretty much has the general idea what's going on here. And one interesting feature I can show you very quickly here is channeled vorticity, such as what you see here, where the vorticity is elongated with the heights. So it's not crossing contours like what you would see out to the east, for example, right here. Let me get that where you can see that. There you see how that's crossing contours. That's more of a advection lobe. This out west in California is more of a channeled vorticity feature. And when we see that, we can assume that the upper level jet is going to be located right here. Maybe right directly in that pattern. And you know, that makes sense because if you have a jet there, you're going to get this kind of rotation on that side, and on the other side you're going to get cyclonic rotation on the other side. So this is going to be cyclonic vorticity here in negative, cyclonic vorticity on the other side. So you would see the patterns kind of elongated like that, and that's exactly what we see here on this chart here. And you can go ahead and use that principle to go ahead and just drag the jet right down the middle like that. So without even looking at isotachs, that'll give you a good way to find the jet locations, and you can see it punching into the back of this cloud feature right here. So that's yet another way you can use all your tools to find a consistency between all the products. Okay, so back on track. Let's go back to our regular charts. Yeah, I'll let you see this very quickly. This is the water vapor imagery. And there's that little bit of shortwave energy that we saw over northern Nevada. and behind that a little bit of subsidence on the back side of that shortwave. And we looked at this one also. In fact, you can see some transverse banding right here. That's going to be a good indicator of clear air turbulence. But I'll show you a very cool feature here. Looking at Florida, see this red mark here? So what would that be? That's likely to be subsidence, very strong subsidence. This is indicative of very dry air. The satellite is receiving a whole lot of radiation from the ground that's not being attenuated in the moisture absorption spectrum by mid-level moisture. So that's kind of a mouthful, but the idea is that there's no moisture in the atmosphere blocking the infrared path going from the ground up to the satellite. So this looks hot to the satellite in the moisture channels. So this indicates that we've got very dry conditions here or very hot conditions. It's probably not very hot there, so we know that this is pretty dry. So let's check out the surface chart. You always want to kind of put the products together and kind of see what's going on. And what do we have? Well, we've got 63 dew points at the surface, but it's a good bet that there's a lot of dry air just above the surface. There's a very clear look to the plots here. And just to make sure we're not too far off base, I'm going to look at the soundings. So let me click on, let's see, TBW, Tampa. I guess we can give that a try. And at Tampa, yeah, we do have a little bit of deep moisture all the way up to 10,000, but dry air above that. So where are we getting that dry air signature? Let's try Jacksonville. So we're trying to find out why we're getting that very strong dry air signature. Okay, here's a lot more dry air for sure. A ton of it up above 6,000 feet and some in the lower levels too. Just this very thin, saturated layer at about 5,000 feet. Does that? This is Jacksonville, so let's go back and look at the product. That's going to be up here. That's not quite in the core. We've got to pick something that's kind of like right on the coast. I don't think we have too many radiosonde stations there. I guess I'll just try Miami very quickly. Let's see here. They look kind of moist there on the south side. And finally, I'm going to look at the 12Z data for Tampa, just in case something has changed. Okay, so 12Z data. Yeah, this is much drier. So we go from 50s near the surface all the way down to, this would be single digits and teens dew points up at about 6,000 to 7,000 feet. So this is very dry air just off the surface. So where's that coming from? I went ahead and ran that high split model and came up with this. This is the trajectories at Vero Beach, right in the middle of that splotch there. So it's showing that, yeah, there is a little bit of moisture that kind of originated near the surface, near the ocean right there. But once you get off the ground, there's some very subsident air that has descended all the way from 3.5 to 5 kilometers. That's about 14,000 to 18,000 feet, all the way down to about 4,000 to 6,000 feet, which that's a lot of subsidence. And where did it come from? It came from the mid-levels over the northern plains. So you can see that there's a lot of three-dimensional motion going on in the atmosphere, and you kind of want to keep aware of that as you work through the charts. Okay, so no audio problems, everything looking good. Let me check my levels. Yeah, they're peaking all the way up into the yellow, so I think we're good. Okay, we'll look at the Terra satellite at Florida right there. Yeah, that looks very dry. You can see the vegetation very clearly there. But as far as the rest of the U.S., looks like a lot of probably overrunning type clouds in Minnesota. And there's our storm system working off the west coast. So we went ahead and covered a lot of stuff right there. So let's see here. I need to clear off these titles. Sorry, I didn't know those were in the way. There we go. It's a little bit better. So let's go to our preliminary frontal analysis. Just very quickly, we're going to go something like that. Cold front down around the Carolinas. Another cold front coming into Colorado from the Dakotas. Then maybe a bit of a tail end coming into Southern California, kind of like that. Because this area is definitely way back in the cold air. And this would be a transition zone right in here. And you can see it looks like a secondary front up to the north. See that transition zone right here? So we would take that and maybe draw a front kind of like that. And there's the high pressure area north of Yellowknife driving that front. So this has the potential to sweep southward through Edmonton to Calgary and give our Canadian viewers there a little bit of cold weather. And in the Great Lakes area here, it looks like a very strong warm air advection pattern. So that explains a lot of those clouds you're seeing there on this image. You see all this stuff over Ontario and Michigan and Minnesota. That's all lift in that warm sector. And we haven't covered isentropic lift. We need to do that sometime soon. But that's going to be the cause of that. Hang on, I'm lost here. Okay, there we go. So you see how the thickness and the isobars, they form these boxes, and there's a lot of those boxes. So that's going to be your warm air advection area. Here we don't have any boxes here in northern Manitoba. So there is a frontal gradient there, but there's not advection taking place there. Same thing in the high pressure areas, no boxes. So this is where your warm air advection is maximized, and that's where you're going to get some of the strongest lift in the lower and mid levels of the atmosphere. Okay, so we'll go into our forecast here. Let me set that for this evening. So you know how all this goes. Starting out with that right there. And we'll move forward into the work week. Frontal system over the Dakotas moves up in Ontario, kind of a northeastward track. And that leaves this little frontal boundary hanging on across the Great Lakes area. High pressure dominating Georgia. And here comes our next front that we talked about up in Alberta, sweeping southeastward. So that's going to affect mainly the Great Lakes area in the northeast U.S. Kind of a little bit of an Alberta clipper, and there's the core right over James Bay. And this is going to be Thursday at 12Z. So that hits the northeast U.S. pretty hard there. Very good cold pool, maybe a little bit of cold core convection, like some snow showers, rain showers in that area. Nothing for us here in the U.S., in the central U.S. Actually, we've got high pressure right there, 1033 millibar high over Oklahoma. So, yeah, we're going to get a little bit of that. When does that come through? Looks like right here. This is on Thursday morning. There it comes through Dallas. So that's about 2 or 3 days away. That's more of a kind of like a more of a density surge, I guess. Not much of a front, really. And then moving forward to the weekend, looks like high pressure over the central U.S. right there, continued cold over the northeast, and pretty stagnant across the Rocky Mountains. Then the start of next week, a week from now, it's like a new front moving into the central U.S. right there. Things stay pretty nice in the eastern U.S. And then by the middle of next week, that front sweeps through the plains, about like that. Strongest push is limited to the Great Lakes area. And then we get to the end of the period, November 10th through 11th. Looks like a little bit of a southeast U.S. system right here. Again, most of the action up in the northeast U.S. You guys are taking all the fun here, leaving the Rockies and the central U.S. pretty quiet. And that's about it. 336 hours, that's way out there, so I'm not going to worry about that too much. But there it is, showing a little bit of action here in the central U.S. We'll see if that pans out. Okay, I think this went off without a hitch, and looks like kind of quiet in the chat room. I guess a lot of people are busy with Halloween, but hopefully we'll see you all tomorrow at the same time. And I thank you for watching, and we'll see you tomorrow. Thanks.